In this video, we're going to look at some questions on L'Hopital's rule. So we have to take this limit. The first thing we're going to do is substitution. So when you substitute, you have 4 minus 4 is 0, and then you have 4 minus 12 plus 8 is also 0. So when you have a 0 over 0 situation and you apply the L'Hopital's rule, you can take the derivative of the numerator over the derivative of the denominator. Then you substitute again. You'll have 2 times 2 is 4 minus 2 is 2. 2 times 2 is 4 minus 6 is negative 2. Therefore, this limit is negative 1. So likewise here, first do the substitution. So you're going to have 1 minus 1 minus 2 plus 2 all over negative 1 plus 1. That is 0 over 0. So I can apply the rule. I take the derivative of the numerator over the derivative of the denominator, substitute again. 4 times negative 1 plus 3 times positive 1 plus 2. Negative 4 plus 3 is negative 1 plus 2 is positive 1, and that is my limit. Okay, so here, as x approaches infinity, the numerator goes to infinity and the denominator also goes to infinity. So because it is an infinity over infinity situation, I can apply the rule. So I have 12x squared minus 4x over 3 pi x squared. Now again, this is an infinity over infinity situation, so apply it again. And I take the derivative of the numerator, 24x minus pi over 6 pi x. Now again, I have an infinity over infinity situation. So I apply this again and I end up with 24 over 6 pi, right? So which reduces to 4 over pi, and that becomes my limit. Okay, next one is this. So I substitute first. Tan 0 is 0 minus 0 is 0 over 0. So I take the derivative. I have secant squared x minus 1 over 3x squared. I substitute. Secant 0 is 1, so I still have a 0 over 0 situation. So I take the derivative of the numerator and denominator again. So secant squared x, I have to apply the chain rule. So I have 2 secant x times the derivative of secant x is secant x tan x all over 6x. Now, secant 0 is 1, but tan 0 is 0, right? So this becomes 0 over 0. So I'm going to do this a little bit quickly. So this is secant squared, 2 secant squared x tan x over 6x. That is my question. So I'm going to take the derivative again now because I had a 0 over 0. So I have to apply the product rule. So I keep the numerate the first term as is times the derivative of the second term plus keep the second term as is times the derivative of the first term. Okay, so this is what I have all over 6. Okay, so now I can substitute. Secant 0 is 1. So I have 2 plus this whole thing becomes 0. So I have 2 over 6 is 1/3. Okay. Okay, here, as x approaches pi over 2, cosine approaches 0. So this is secant, right? Okay, so pi over 2 from the left. So this secant is going to be, secant is cosine is 0, so secant is going to be approaching infinity. So infinity over an infinity situation. So we are going to apply the L'Hopital's rule. Take the derivative. This will be 2 secant x tan x over secant squared x, which can be simplified to 2 tan x over secant x, right? Sine over cosine. So I can simplify this. This is 2 sine x over cosine x all over 1 over cosine x. So this can be rewritten as keep your numerator as is and flip your denominator. So this and this will get cancelled. So this just becomes the limit as x approaches pi over 2 from the left of 2 sine x. Sine pi over 2 is 1. So this limit is 2. Okay, so here I have a product, so I cannot apply this, right? But I can rewrite this a little bit. So secant x is nothing but 1 over sine x. So I can write it as a quotient instead of a product like so. Then I substitute, I have a 0 over 0 situation, and I can apply the L'Hopital's rule. I take the derivative of the numerator, derivative of the denominator, and then I substitute and I get my limit.